Hello guys, in this video I'm going to show you how to solve k-largest numbers problem. So given an unsorted array of numbers, find the k-largest numbers in it. So for given input of 6 elements, 3, 1, 5, 12, 2, 11, and it is unsorted. For k equal to 3, what is the 3 largest? What is the 3 largest numbers in the array? So as you can see, the 3 largest number is 5, 12, and 11. So for this kind of problem, when you are asked to find either k largest or k smallest, think of using a heap, because with a heap you always have access to the smallest element or the largest element. Depends on whether it's min heap or max heap. So the idea here is to always keep the heap size equal to is around k elements in the heap, right? So for example, let's say, of course we need to iterate to the input, right? We need to iterate to the input. For first k elements, for 3 elements, we're gonna just push it in the heap. What we need here is a min heap, right? Because we need to know what is the current smallest number in the array. So whether we want to update it with a larger number, so that at the end of the loop we can have all the largest number in the array. So let's try to run through our example. We need a min heap, right? So for min heap, we always have access to the smallest number in constant time, and in this case 1, right? So we are here, so the next one is 12, right? We compare 12 with the smallest number, right? Do we want to update our min heap? Yes, of course. 12 is greater than our smallest number, so probably we want to add 12 to our min heap and to pop out the smallest number. So as we iterate to the array, as you can see, the min heaps is updated. It comes closer to our output, right? So the next one is we need to mark the smallest in our tree, right? The next one is 2. Compare with the smallest one. It is smaller than the smallest one, so it shouldn't be put in the min heap. The next one is 11. 11 is greater than 3, so we want to add 11 in and remove 3 out. So we exit our loop, and as you can see, our min heap is now contains three largest number. So that's pretty much it about our algorithm. To find k largest numbers, we need a min heap. To find k smallest numbers, we need a max heap, right? Because always we need to have access to, in this case, the smallest one in the min heap. For each iteration, we want to update our heaps. So let's code it down. We need a min heap, right? I will initialize a min heap. Gonna use third-party library because JavaScript doesn't support heap data structure. We started with no, and the third arguments will determine if it's marked for min heap. For min heap, it is a b minus a. For max heap, is a minus b. So we do process, right? So after the process, we end up with min heap storing k largest elements. So we need to convert it into array before returning. Okay, min heap, right? So what kind of process we want to do here? Of course, we want to iterate to the nums array for that. Maybe I want to have access to the index. Let I equal to 0, I less than num size I plus plus. So the idea here is for each iteration, we want to, for each iteration, we have to push one in. We want to push one element in, right? There are different ways to code it. In this case, we can, for every iteration, we can just push it in, right? But until the k minus 1, right? We want to start popping out, right? So maybe after 3 numbers, our min heap, there are a total of 3 numbers, right? For the 4th number, we still add it in, right? So we still add it in. So internally, min heap will update its mean, right? So it updated means, and we want to pop it out after. So the element is pop out can be the current one or a new one, right? So for this way, our code will be a little bit clean and shorter. Later, I'm gonna show you how to improve on it to make it better in terms of performance. So for every iteration I want to push element in the min heap. I want to add the current, which is I, but since index of k, which means we have total k element in the min heap already, right? So in the index of k, if I greater than k, so when this is the case, when this is the case, the min heap should have k plus 1 element, right? And we want to pop out the smallest. So I want to pop out in case so the idea here is, since 12, our min heap can have k plus 1 element, in this case 4 elements. We add 12, and now we remove the, sorry, here should be 315. Since 12, we add 12, we remove the smallest one, which is 1, right? Smallest one is now 3. We go to 2, add 2 in, right? And now the smallest one is 2, so we remove 2. And now it's come to 11. It's 3, it's the smallest, we remove 3, right? So that's pretty much it. Let's run the test. Okay, it works, but even though the code works fine and the time complexity is of n, which is I think is very good, but there's still we still can improve it. There are a couple of points here, which is as you can see, since the k minus 1, we still add we still add every element, every number in the min heap, whether it is in this case, for example, 2, it is smaller than all the number in the min heap, right? But we still add it in, then pop it out, so it kind of like a waste of time doing that. So probably we just want to add a number in the min heap if that number, for example 2, is greater than the smallest ones, right? So by that by that observation, we will limit our min heap always has 3 elements at max, right? So if we add 2, we don't want to add 2 if it is less than 3, which is the smallest one. So in order to do so, I'm gonna fix our code a little bit. So I will comment the previous implementation in, and so how we can, for we don't want to push element, we don't want to push everything in, right? We just want to selectively push in the element that is larger than the smallest in the heap, right? So but for the first k elements, right, for the first k element, it is the exception because it always the first always the smallest until that time, at the time, right? So probably for the first element, I just want to let I equals, for the first element, I just adding the heap, right? Nums I, but since the k since index of k, I probably don't want to push it in if it is less than. So the condition here is if the current element, right, it is greater than the smallest in the heap, which is pick, right? I probably want to pop it out, pop the element from the min heap out and add the current to the min heap, right? So let's run a test again. Oh, it's just a matter of order here, I think. So 11, so probably I want to sort it. So we want our result is sorted in ascending order. All right. But 5 of 5 is what's wrong here? Our is not sure what's going on here. Let's see. Min heap get first k element, and since the k we want to only add the min heap if the current element is greater than the smallest one in the heap. Not sure what's going on here. the expected value is 5, 11, 12, but R is 11, 12, 5. Why is that? We call the sort function here. Let's see the test. Probably we want this. Alright, I think it should be working. Okay, so that's it for our k-largest numbers. Thanks for watching. See you in the next video.